Welcome to GoodTecher LeetCode tutorial. Here we are going to solve four-sum coding problem. So given array nums of n integers and an integer target, are there elements a, b, c, and d in array nums such that a plus b plus c plus d equal to target? Find all unique quadruplets in the array which gives the sum of target. So note here, the solution set must not contain duplicate quadruplets. For example here, given array nums that's a 1, 0, negative 1, 0, negative 2, 2. And target value is a 0. So our solution set is like this, array of integers. So we see here there are 3 quadruplets in this array. So like each quadruplet has 4 numbers. So 4 numbers, they add up together or equal to the target. So four-sum is a follow-up question for a popular coding problem you may think before, that's two-sum. So two-sum is about in an array we need to find 2 numbers add up together to the target. And two-sum is a very popular coding problem, and two-sum has many follow-up questions like three-sum. So for three-sum we need to find 3 numbers in an array add up together to the target. And this time four-sum, it requires even more to find the 4 numbers in the array to add up together to the target. So it sounds more difficult. So like a four-sum sounds more difficult than the two-sum, three-sum coding problem. But actually, underlying the hood, the four-sum has a similar pattern with a two-sum, three-sum. So once we figure out the similar underlying pattern between the four-sum, two-sum, three-sum coding problem, we will easily figure out the very straightforward approach to solve this four-sum coding problem. So here, let's take a look at some example here. So suppose we have this input array that's 1, 0, negative 1, 0, negative 2, 2. And our goal is to output array of integers. So inside this big array, we have like quadruplets. So each quadruplet has 4 numbers, and 4 numbers add up together should equal to the target. So when we see this array, the first step we should do is to sort this array. Because this is an unsorted array, so we can sort this array to have a more clear vision about the patterns behind this array. So we sort this array into ascending order. So it will be like this. So negative 2, negative 1, 0, 0, 1, 2. So these 6 numbers become this sorted array. So this sorted array. So our goal is to find the 4 numbers equal to the add up together equal to the target. So this four-sum coding problem. Four-sum. So we can introduce an index variable called I. At the beginning, you just start at the beginning of this array. So for the four-sum, our goal is to find nums I value plus find another 3 numbers add with this I index number value should equal to the target. So for here, the target is just a 0 at the beginning, and nums I precision at the beginning is a negative 2. So that means we need to find 3 other numbers. Their sum should be the 2, so that they can add up with this I index value equal to the 0. So it's about converting this four-sum problem to the three-sum problem. So for the three-sum problem, so we can introduce another index variable called j. So j just started right behind the I position. So j start here, and the j needs to find. So here is a three-sum. So here is 1 number. So we need to find another 2 numbers. So their sum plus this j index value should equal to the target. But here the target change. The target we see here in the four-sum. For here is just need to find that's equal to the 2. For the j value here is a negative 1. So for other 2 numbers, their sum should be the 3. So three-sum again becomes a two-sum problem. So toSum, if you have seen my previous video tutorial before, that's about the toSum. So for a sorted array, we can use a two pointers technique to solve the toSum problem. So like we have one left index and right index. So left index start at beginning, just at the beginning of the search range part of the index, and right just at the end of this search part of the array. So here the left at the beginning of search part of the array. So left and right, they should move toward the same direction. So left and right, these two index, they are number. We compare with the target. Like we compare with the target. If their sum add up together is greater than the target, we should make the right one left forward. So decrease the bigger number so that we can compare again with the target value. So if that's just still like a smaller than the target, so that means our smaller number should be bigger. So smaller number be bigger, that means the left should move to the right, and compare again until we find whether there's two numbers they can equal to the target. So for the toSum, is a nums left and plus nums right. They should equal to the target. So for their target here is just 3, as we see in the 3 sum. So there should be the 3. So for this example, we see here that 1 plus 2, when left at 1 this position and right at this 2 position, so they should add up together to the 3. So now we find one quadruplets. That's when I add a -2, j at a -1, and the left at 1, right at 2. There's one quadruplet, -2, -1, 1, 2. That's one quadruplet. That's equal to the target. To find the next quadruplet, we can move like a left toward right and right toward the left. Or like for the toSum level, if we still not find, we can go back to the 3-sum level. Like make the j right forward to check whether from another one we can find. Yes, we can find like from the -2 and j when it's at 0, and there's another quadruplet. And again, if that's finished, that in the 3-sum level iteration, we can go back to the 4-sum level iteration. So move the I to the next position. So move the I start from the -1, where to find the 4 numbers add up together to the target. Yes, we can have like a -1, 0, 0, 1. That's another quadruplet add up together to the target. So we have this 4-sum. We see here like using the 3-sum by introduce a 3-sum, 2-sum approach. We can also help to solve this 4-sum problem. So we can use this approach to build up the codes to solve this problem. Like in the real coding, we should also pay attention to remove the duplicates so that we won't have a duplicate quadruplets. So like here, when the left, like there's 2 zeros here. So when left move to the second 0, we can compare whether the second 0 just equal to the first position left value. If that's still the same, that means we can just skip to the next iteration so that we won't put the same quadruplets into the final result. Okay, so here we can come back to the problem, do coding to solve this problem. So as we see here, the output type, return type would be list of integers. So that's result. So let's call it as result, and that's our final output. As we just mentioned, we should sort this array. We can sort this array first. So arrays.sort will make this input array into ascending order. So now we can do our 4-sum iteration. So at the beginning, I just start from the first beginning of the index, and since we are find the 4 numbers, so I can terminate at the ith nums minus 3 position. As we mentioned, we need to pay attention to the duplicates, and we need to handle the duplicate scenario so that if I is not the first one and this I position value is equal to the nums I minus 1, so we should continue to the next, just keep this one to the next iteration, and then we can go to the 3-sum level. 3-sum level, that's j. We introduce a j variable, so j just start right behind the I, and j terminates at the nums.length minus 2 position. So here j increase, and also we need to handle the duplicates. Handle the duplicates, just check if the j is not the first one. For here, the j not first one is I plus 1. So if the j is not the first one and nums j is equal to the nums previous j position value, so we can skip and continue to the next iteration. Then we can we need to find, for this j position, we need to find another 2 values. Another 2 values equal to some target. So that's for the 2-sum problem. For the 2-sum problem, we can introduce 2 index variables, that's left and right. Left and right. So left should just right behind the j, and right just at the nums.length minus 1. And for the 2 pointers, since we already sorted this array, we can use our 2 pointers technique. So while left is smaller than the right, so we can have integer variable to check these 4 numbers added together, how the sum compare to the target. So right now the nums I plus nums j plus nums left plus nums right. And we compare this sum with the target. So if the sum is smaller than the target, so if the sum is smaller than the target, that means the smaller number should become bigger. So we can increase the left. Else, if sum is greater than the target, if greater than the target, that means the bigger value should become smaller. Should become the smaller, we make the right index left forward. Else here means just a sum is equal to the target. For that case, we need to store this 4 numbers. Store these 4 numbers, so we can introduce one as an integer. Let's call it as a quadruplets. So this is a quadruplets. New array list. So we can add these 4 numbers to the quadruplets. Quadruplets.add. So nums I quadruplets.add nums j quadruplets.add nums left quadruplets.add nums right. And we have one quadruplets, and we should add this quadruplet to the result. So we add this quadruplet to the result. And make the right, since this finish, and we can go to the next place. So make the left, right forward, make the right, left forward. And also we need to handle the duplicates. So when we increase the left and when we decrease the right, we should compare whether the next left is just the same as the current left position. So while left is smaller than right, and if nums left is equal to the previous nums left minus previous left, so that we can continue to increase the left. So similarly, while and right and the nums right just equal to the previous right, we can decrease the right. And here we have other iteration, so we can come back to return the final result. Okay, before submit, we can quickly check if there are some typos. So at the beginning, we introduce list of integer, that's the final result we want to return, and we sort this input array in ascending order. And then we do the iteration, introduce an I variable and handle the duplicate. So if there are duplicate, we skip to the next iteration and then go to the 3-sum level. So for current I position, we need to find another 3 numbers add up together to the negative value of this like the target of add with this I position equal to the target. So for this 3-sum level, we also handle the duplicate, and then introduce a 2-pointers technique. And we use this 2-pointer technique, and inside the while loop we see here we have this sum of the 4 numbers and compare with this 4 numbers sum with the target. If that's smaller than target, we increase a smaller number, and if it's greater than the target, we decrease a bigger number. And also, like if the sum is just equal to the target, we have a quadruplets variable and add these 4 numbers and add this quadruplets to the result, and increase the left, decrease the right, and also doing the remove the duplicates, like while left smaller than right, and the next left just equal to the current left, we continue to increase the left. Similarly, if the next right is just equal to the current right, we decrease we can continue to move the right to left forward. And finally, we can just return this final output. So looks correct, so we can click the submit. Okay, accepted. So very beautifully, we have this very straight approach to solve this 4-sum coding problem. So as you can see, we use like a 4-sum, use a previous 2-sum, 3-sum approach to help solve this 4-sum coding problem. And for this coding problem, the time capacity, like for this approach, would be the n cubed. So time complexity would be n cubed. And for the space capacity, it's also the O n cubed for this approach. So like you see here, this 4-sum, looks more difficult than the 2-sum, 3-sum coding problem. So I guess in the real coding interviews, maybe it's very few occasionally you will encounter this 4-sum coding problem. In that case, it means that the interviewer is using a very difficult coding problem to test your skill. But we can still make practice, just like nowadays we see in World Cup in soccer field, like Cristiano Ronaldo, he may do in training for practice his free kick shooting, and maybe in the real game he will only have a 1 or 2 times opportunity to make the free kick in the real game. But since he practiced more and so that he can build skill and to make a goal in the real game. So it's similarly for us, when we do the 4-sum this problem in our practice, so we can be more confident when we do the real coding interview. Then we make more practice, and we become more confident and more professional too. So no matter what problems we facing, we can find like a similar pattern and solve those problems. Okay, so here is about this four-sum coding problem. So thanks for watching. Thanks subscription to GoodTecher channel. So see you next time.